Hello, my name is Bryce Jensen, and I will be going over the video portion to assignment 1. This is my implementation of the 8 puzzle search, and I went with Python in order to code this up. I modeled my program with an object-oriented approach, using the 8 puzzle class as the object that stores all the data and state values. I calculate my heuristics right in the constructor, and with the use of the getDistance method here. My successor function is expand, where I check for all of the successors, and then I return all the possible children back into a list called children and return that. In order to print out the solution, I have a method for solution path. My breadth first search method takes in a start state as an argument, and then I declare an empty list for nodes that have already been seen. I store an instance of the 8 puzzle object into node. I check for the goal state, do a goal test. If it is not goal, then I declare the frontier list, which is where nodes waiting to be seen will go, and I append the node to the frontier. While frontier is not empty, I pop the node, add that to traverse list, and then expand that into children to get the successors. I then loop over for child and children. I check for repeated states, and if there are no repeated states, I'll do another goal test, and if it's not goal, add that child, then it loops over. Depth first, very similar. The main function here is while frontier is not empty, I will pop the node, expand it, and then look at each child and children, do a goal test on child, and if it's not the goal, then I append it to frontier. For these, I am just using the Python data structure built-in list type because they are uninformed searches. For uniform cost, I do something very similar. I store 8 puzzle object into node. I'll do a goal test before I even start my loop. My main loop function goes, it pops the node, it expands the node into children, I add that node into traversed, and then I look over each child and children. I do a state check to make sure that I'm not adding in states that already exist, do a goal test, and then add the child node. Lastly, I will do a check here to check for if the path cost of the child node is less than the parent node, and if so, I put the child as index 0 of frontier. Best first search, very similar, except now instead of using just a list, I actually have a priority queue as frontier, and while that priority queue is not empty, I will grab the node from the tuple that I put it in as. The tuple contains the heuristic that the node will be using. Count is the priority, and then the node is itself. So I grab the last indice of the tuple, add that to traversed, and then I do a goal test. I expand that node into children, and I check for each child and children, check for repeated states. If it is not in traversed, then I will increment my count, aka the priority, and then pop that child into frontier. For A star, very similar, except in my main loop, I grab the node, add it to traversed, I'll check if it's goal, then I'll expand into children, then go through for each child and children and make sure that I'm not doing any repeated states. And the only difference between A star 1 and A star 2 is the heuristic that it's using that is denoted inside the tuple. And I can go ahead and run this. And that is my assignment. Thank you.